Right, here's the first chi-squared, question 1, Mendel and his peas. What do you call an angry pea? Grumpy. Very good. Right, why are we doing chi-squared? We're doing chi-squared because here's our little chart here. And are we looking for an association? No. Are we looking for differences in the means? Well, there's no means here. And what we do have is numbers in categories. So a number of round peas and a number of wrinkled peas. And so we're going to use our chi-squared. And what Mendel found here is a total number of peas, and so many were round and so many were wrinkled. And we're wondering whether this fits into our expected ratio of 3:1. Now, when we look at those numbers, that's not an exact 3:1 ratio, and in our expected, are we going to put those numbers in? So are they different enough or similar enough to our 3:1, or what do we think they're within our kind of 95% confidence level? So let's have a go. Null hypothesis. This is generally there isn't a difference, or there isn't, that's the sort of way this starts. So apart from we need some keywords in there. So there's no significant difference between the observed, that Mendel observed, and our 3:1 ratio numbers. So there is no significant difference between observed and expected frequencies or numbers of, and the two are round and wrinkled, round and wrinkled peas. So we are looking, if we accept this null hypothesis, then the 3:1 ratio is right. If we are rejecting this null hypothesis eventually, that means the ratio must be different in some way. It doesn't fit into the 3:1. So let's go through it. And we've got round and wrinkled. What did Mendel find? The observed round was 423. The observed wrinkled were 133. What would we expect? Right, this is the bit that some people find difficult. First of all, what's our total number of peas? 556. So I'm just going to write this in here. Total is 556. Let's just check that. Is that right? So these two numbers must add up to our total. Let's try that. 423 plus 133, 556. Yeah, lovely. Right, so 3:1. So if we're wanting a 3:1, then we must have total is 556, and then all the 3 and the 1 must add up to that. So we're going to get our 556 and divide that by 4. That's 139. So 139, 139, 139, 139. And so we're going for our round, which is the 3. So our round ones are going to be 3 of those, and our wrinkly ones, and then our wrinkly ones are going to be just this 139. So that will be 139, and our round ones will be 139 times 3 is 417. So as you can see, the the observed numbers that Mendel got are slightly different from our kind of perfect 3-to-1 ratio. So that's what the test is. Are they okay, or is there some problem? So O minus E. So we've got our, this is our O, this is our E. So O minus E, 4, 2, 3. 423 minus 417 is 6. 133 minus 139 is minus 6. But as we are squaring this, you can do this in your head, so that's going to be 6 times 6 is 36. A minus number times another minus number is a positive number, so that is again just 36. So that's why that steps in, to get rid of any minus numbers. And then we've got 36 divided by E, which is our expected frequency. So 36 for round divided by 417 is 0.0, let's go for 86 here. Let's round it off. That's 0.09. It's okay to round on these, and if you, when you get your chi-squared later and it's very, very close to your critical value, then you might need to go back and put some more decimals in. But for the moment, we'll round these off to nice numbers. So that's 0.09, and then we've got, for wrinkled, 36 divided by E, which is 139, is 0.2, we'll round that off to 26. And then we add those up to get our chi-squared value. So 0.09 plus 0.26 is 0.35. So that's our value for chi-squared. How many degrees of freedom are there? Well, this is a number of classes minus 1, so that is the number of classes minus 1. So the number of classes is 2, round and wrinkled, minus 1 is 1. So that's 1 degree of freedom. What's the critical value from the table? Here's your table. Degrees of freedom, we've just said there's 1. Critical value is this then for 1, 3.84. And now we are just comparing our chi-squared against our critical value. I always start off with the way I remember it is if chi-squared is bigger than the critical value, you can reject your null hypothesis. That's what I've committed to memory. If chi-squared is bigger than the critical value, you can reject your null hypothesis. So I would go, it's not bigger, so I'm going to have to accept my null hypothesis. What we've written out here is the kind of the full thing that you have to say. So our calculated chi-squared value is it larger or smaller? So 0.35 is smaller than the critical value. And that means that there is more than 5% probability that the differences are due to chance. We are accepting our null hypothesis. So that means that the ratios are okay. There is some slight differences, but for the error that we're willing to accept of 95% confidence, then we're fine.